Here are the notes for 8.3. We'll be doing mole conversions. All right, so this is our goal for today. We're going back to dimensional analysis to convert between molar mass, moles, and molecules and formula units of a substance, and we'll learn about those in a second. So remember from first semester, converting when we use moles to go between grams and moles, that's when we use the periodic table. So we would look at like nitrogen, for example, and we would see nitrogen has a mass of 14.01. And what that means is there are 14.01 grams of nitrogen in 1 mole of nitrogen. If we want to go between moles and atoms, that's when we use the 6.022 times 10 to the 23rd number. And then you can also add to your notes here. We'll learn about these in a second. Not just atoms, that was first semester. Now we're dealing with different compounds. So we have molecules we can add to that and formula units. So 1 mole isn't just 6.02 times 10 to the 23rd atoms. It's also 6.02 times 10 to the 23rd molecules or formula units. If we are talking about covalent compounds, those are called molecules. So like a collection of water molecules here, if you look on the right side, one piece of that that's still water is called a molecule, and that would just be the formula H2O. Ionic compounds, you don't call them molecules because of the way ionic compounds are structured. They usually form a lattice, so instead of calling them a molecule, we just call them a formula unit, and that means 1 sodium and 1 chlorine ion together. And it's just because they're ionic that we don't call them molecules, so the name for that is formula unit. But in terms of counting, same thing as a molecule. All right, so just to recap, since 1 mole isn't just 6.02 times 10 to the 23rd atoms, it's 6.02 times 10 to the 23rd of anything. That means if we have 1 mole of something, that's 6.02 times 10 to the 23rd molecules, or also 6.02 times 10 to the 23rd formula units. So here is where we get into our math examples. This is what we'll have to do. We'll have to do different conversions. So in this example, we are converting 2.27 times 10 to the 23rd molecules of potassium tribromide, PBr3, to moles of PBr3. So if you can remember from first semester, what we're doing here is we are going to take our starting value that we're given, so 2.27 times 10 to the 23rd molecules of PBr3, and we are going to put it over 1 in a fraction. So we always start like that. Take our starting unit, put it over 1 in our conversion math that we're about to do. From here, we want to look at what we're converting into. So we're going into moles. The conversion between molecules and moles is to use that 6.02 number. So 1 mole is 6.02 times 10 to the 23rd. And then since we start with molecules on top, we put the molecules on the bottom. So 6.02 times 10 to the 23rd molecules of PBr3 goes on the bottom because remember, we're trying to cancel out molecules. From there, we're converting into moles. So we put moles on top. And then we do our math, multiplying across the top, multiplying across the bottom, and then dividing what we get. So in this case, we get 0.0377076 and some extra decimals. But when we do this, we have to remember our sig figs. So we look at our values. We have 3 sig figs here. So when we round our answer, we go to 3 sig figs. So we find the third significant digit here, which is the 7. Check the next one. It's a 0. That means we don't round up. So we keep it at 0.377 moles of PBr3. Here's the second example. We're converting 2.1 moles of Li2O to formula units. And remember, a formula unit is just like the ionic version of a molecule. So we're going moles to formula units. So pause the video here and try to do this one on your own before resuming it to check how you did. All right, when we do this one, we're starting with moles. So we put that over 1, and we want to go to formula units. The conversion between moles and formula units is that 6.02 times 10 to the 23rd number again. And when we show our work to abbreviate it, instead of writing out formula units each time, we'll just abbreviate that fun for formula units. All right, so from here, we start with moles on top. So that means we put moles on the bottom of our conversion factor, and 6.02 times 10 to the 23rd goes on top. And then we do our math, multiply across the top, and we get 1.2642 times 10 to the 24th. Check our sig figs. This time we're limited to 2 sig figs because of the 2.1 moles here. So I just round to 2 sig figs. Here I get 1.2, but then since that next digit is a 6, I round it up to 1.3. So my final answer is 1.3 times 10 to the 24th. Don't forget the scientific notation part. Formula units of Li2O. Moving on to example 3. Here we're converting 27.3 grams of Li3PO4 to moles. So when we do this one, whenever we see grams, we again start the same way, but whenever we see grams involved in our problem, we're going to need to use the periodic table. So if you see grams, you will need to use the periodic table. The last 2 examples didn't have grams in them. We didn't need to worry about the periodic table. Now we do. When we look at this, our conversion factor, like if this was semester 1, it would just be a single element, and we could go to the periodic table and find the average atomic mass of that thing, and we would just use that number. But now we're dealing with compounds, so here's where we need to use what we started in 8.1 and 8.2. We need to find the atomic or the mass of this whole compound, and the way to do that is what we did in 8.1 and 8.2. So we look at Li3PO4. We find the total mass of this compound here. So lithium, there are 3 of them. Lithium, each one has a mass of 6.94, so we just multiply them. And then we do it for phosphorus and oxygen. And if we add them all up, we would get a total molecular mass here of 115.79 grams. So that's our conversion factor. So we don't get this directly from the periodic table. We have to do our math like we were doing earlier in the unit to get the mass of the whole compound. But once we have that, now we have our conversion factor between grams and moles, which is what we need because we're going from grams to moles. So I started with 27.3 grams on top. So I put my conversion factor, grams goes on the bottom. So I use that 115.79 grams on the bottom. And I go to moles on top, which is what I want. So here I can do my math again, and I get 0.23577. Check sig figs. I have 3 sig figs on the first number here. So when I find my cutoff point, there's my 3rd sig fig. Next number is a 7, so I round it up. So my final answer is 0.236 moles. In example 4 here, we want to convert 0.921 moles of iodine pentafluoride to grams. So when we do this one, we're going to start. Actually, you can pause the video here and try to do this one on your own before you continue. All right, so when we start, we're taking our starting unit, 0.921 moles. We will put it over 1. Then we want to convert to grams. Again, if we see grams, we're going to need to use the periodic table and find the compound mass that we learned earlier in the unit. So IF5 has 1 iodine and 5 fluorines. So we would get a total mass of 221.90, and that's 1 mole. So this is our conversion factor. And then from here, we'll put moles on the bottom and grams on top. And then we do our math. We get 204.36. Check our sig figs. We have 3 sig figs here and 5 on this one, so we're limited to 3. So then my final answer is just 204 grams. now on to our last category of conversions here, and this is one where we'll need to do multiple conversions. So this is a multi-step process because we're going from molecules to grams, and we don't have a direct conversion between molecules and grams. So when we do ones like this, we'll need to go molecules to moles and then moles to grams, if you remember doing this from first semester. So when we look here, we're going molecules first. So that's our starting. But again, I don't have a conversion factor directly from molecules to grams. I do know molecules to moles, and I do know moles to grams. So we need to use both of those conversion factors together. So again, if we see grams, we're using our periodic table and finding the compound mass. So SO3, sulfur, has 32.07 for a mass. Oxygen, there are 3 of them for a total mass of 48. And that brings my compound's total mass, if I add them up, to 80.07. But again, remember, that's equal to 1 mole of this thing. And I don't know moles yet, I just know molecules. So we'll need a second conversion factor going from moles to molecules. So we're starting with molecules. So we put molecules on the bottom, and then moles goes on top. Then we need one more, because remember, we're trying to end in grams, so we need one more conversion factor, where if I have moles on top of my second fraction here, it goes on the bottom of the third one, and then I go to grams, which is what I want to end in. And now I do my math, multiply across the top, multiply across the bottom, and then divide them, and I get 284.63. Lastly, I need to check sig figs again. So I have 3 sig figs on these two, and then 4 sig figs on this one. So I'm limited to 3 sig figs. So I take my 284.63 and I round it up to 285. And here's our final example. Convert 48.6 grams of Na3N to formula units of Na3N. Once again, this is like example 5, where it's going to be a multi-step conversion. So one last time, you can pause the video here and practice this before resuming. All right, to get started on this one, we're starting with grams. Again, I see grams, so I know I'm going to need my periodic table. So I use my given unit over 1, so 48.6 grams over 1. Then I find my compound mass, so Na3, N1, add it up, and I get a total mass of 82.98. So that's what I'm going to use to get to moles, but I don't want to end in moles. My ending unit, I want to end in formula units. So I'm going to need to take my moles that I get from my first conversion and then use the 6.02 number to get it into formula units. So I start with my 48.6 grams over 1. Then my next conversion factor, I put grams on the bottom and I go to moles. And then lastly, I have to go moles to formula units. And then I multiply across the top, multiply across the bottom, divide them, and I get 3.52581 times 10 to the 23rd. Lastly, check sig figs. I have 3 sig figs, 4 and 3, so I'm limited to 3. So I round my answer to 3.53 times 10 to the 23rd formula units. And that is it for 8.3.